Assalamualaikum and hi. We are from Group 8. We will discuss a case study that is case study 3 from the topic Wilcoxon-Signed rank test. This case study will be discussed and presented by all the members from our group in this video. Our members consist of Muhammad Hanif bin Muhammad Nizam, Siti Nur Alia Farahi binti Abdul Jamal, Najah binti Zainuddin, Nurul Iman binti Rahim, Farah Najwati binti Zainal, and Najah Awatif binti Muhammad Zalimain. Our discussion will start with the introduction of Wilcoxon test and background from Alia Farahi.
Wilcoxon test and background. France started proposed the ransom and signed rank test in groundbreaking published research paper in 1945. The test laid the foundation for hypothesis testing of non-parametric statistics. Non-parametric distributions do not have parameters and cannot be defined by an equation as parametric distributions can.
Wilcoxon-Signed rank test is a non-parametric statistical test used when comparing two related samples, matched sample, or repeated measurement on single sample, pre or post test to assess whether their population mean rank differ. It is equivalent to the matched sample t-test, allow us to compare two populations that violate the assumption normality. The purpose is to test whether the medians of two paired sets of measurement from the same identifiable population are different from each other. Requirement: the differences is symmetrical, median, not necessarily normally distributed. Wilcoxon test set the test statistic is reported as value of t. Similar to rank sum test, sign test take into consideration the magnitude of differences among the pair of value. Rank sum test only consider the direction of differences but not the magnitude of differences.
Case study 3. A medical researcher wants to determine whether a new drug affects the number of headache hours experienced by the headache sufferer. To do so, he selects 7 patients and asks each to give the number of headache hours per day each experienced before and after taking the drug. The results are shown in the table. At alpha equals 0.05, can the researchers conclude that the new drug affects the number of hours? Show the calculation step by step with the correct answer in your team's video. Contributions from your members will count towards your team score. Answer: null hypothesis equal the drug does not affect the number of headache hours. Alternative hypothesis equal the drug does affect the number of headache hours claimed.
To find the critical value, we must use the alpha value 0.05 and n equals to 7 and use the value in the Wilcoxon-Signed rank test table so we can obtain the critical value, which is 2.
Okay, first of all, we need to calculate the difference between before and after the headache hour. So the formula would be before minus with the after headache hour. For example, 1.1 minus 1.5 equals to negative 0.4. 2.2 minus 1.9 equals to 0.3. 1.8 minus 1.6 and we will get 0.2. Same goes to the others. You can calculate all the way down and we will get the answer. And then for the absolute value, we can simply remove the negative sign that we have been calculated from the difference before this. For example, 1.1 minus 1.5 and we will get the difference negative 0.4, and for absolute value we just remove the negative sign for 0.4, so the absolute value would be 0.4. So when we get the absolute value, it would be easier for us to arrange them according to the rank.
So after arrange according to the rank based on absolute value, as you guys can see, 0.2, 0.3 and 0.4 appear twice. So to determine their rank, we need to calculate the average. So for 0.2, they have two rank, which is 1 and 2. So 1 plus 2 divided by 2, we get 1.5. And for 0.3, the rank is 3 and 4, so 3 plus 4 divided by 2, we get 3.5. And for 0.4, 5 plus 6 divided by 2, we get 5.5. So for the last one, 0.7, the rank is 7. So next for sign rank, the sign kita boleh tengok dari difference. So kalau dekat difference ni sign dia negatif, so dekat sign rank ni akan jadi negatif juga. So 5.5 akan jadi negatif 5.5. Next 3.5, positive 3.5, positive 1.5, positive 1.5, positive 5.5, negative 7 and negative 3.5.
Next, we need to find the test statistic. For the Wilcoxon-Signed test, the test statistic is calculated based on the sums of positive and negative ranks. So here we calculate the sums of positive rank first, and we got 12. After that, we calculate the negative ranks, and we get negative 16. And then we modulus both of this number to make sure we get a positive answer only. So here negative 16 will be positive 16. In the Wilcoxon-Signed test, the test statistic is the smallest one of the two sums of absolute value, which is 12 is smaller than 16. Therefore, the test statistic W equal to 12.
For the deviation part, we have the Wilcoxon test statistic, which is 12, that we calculated from the previous part. For Wilcoxon critical value, we have 2 from the question given. Since the calculated value is higher than critical value, which is 12, higher than 2, this shows there is no enough evidence at 5% level of significance to support and claim that the drug affects the number of headache hours failed to reject null hypothesis. In other words, we say null hypothesis accepted. In conclusion, a new drug do not affect the number of headache hours among the patients. So here is the conclusion part of our group on how to solve the problem in complete the Wilcoxon signed rank test statistic. First, we make the hypothesis where we identify the null hypothesis and alternative hypothesis. Next, we find the differences between the measurement from given data in the question. Then, we can find the absolute value by neglect the positive sign and the negative sign from differences calculation. So we can find the average and we assign the symbol. Next, we sum. We select a small number of absolute value of the positive and negative sum. For the critical value, we can find in the table 9, but we need to identify the n and the alpha. For this question, our n is 7 and our alpha is 0.5, so the critical value is 2. Next, we compare and make a division. We compare the test statistic value and the critical value, then we choose the right hypothesis based on the test statistic value. Thank you.